So we're talking about exceptions. As we brushed upon last time, there are two kinds of exceptions. Checked exceptions are the ones that are mandatory. The classes that throw checked exceptions, you absolutely have to implement. Exception handling. You have to put them in try-catch or throw the exception or put a throws method, a throws clause in the method declaration. Anyways, they have to be handled. Checked exceptions have to be handled somehow. And then unchecked exceptions make your program better, more reliable, so you don't get runtime errors. Checked exceptions are things like file I/O, where they're so fraught with peril that the developers of the file classes absolutely make you handle them, make you handle the errors. You know, file not found or things like that. So we have runtime exceptions, which are unchecked exceptions, and then we have checked exceptions, such as IOExceptions, all the file ones. So number format exception and arithmetic exceptions, and the one that parse returns, I forget which one that was. Maybe that was number format. Those are all unchecked, which is how we've been able to get away with not having to check them so far. So unchecked exceptions are ones that you do not have to check with a try-catch mechanism, but if you don't, then you can get a runtime error and the program will crash. It will terminate ungracefully. So you have two possibilities. One is to use try-catch, or you can write the code carefully so as to avoid the possibility of the exception being thrown. You know, you could check the denominator, the numerator. Yeah, the denominator is the bottom one. You can check it to make sure that you're not dividing by 0, you know. Some things get to be a little bit more complex. You can't prevent the user from entering, you know, bad input. But you could read it in, you know, with next line or, you know, .next, and then do some careful validation on it to make sure that it's, you know, that it's an integer or whatever. But honestly, it's a lot easier just to catch the exception rather than do that. You know, doing formatting of a string to make sure that it is a floating point number, a valid floating point number, is pretty annoying. So you can get exceptions doing other things than what we've been talking about. Adding, you know, removing things from a list. If you have an array list, and here, let me zoom in, and you call .remove on it by an index, but it's a bad index value, you know, it'll throw an error. Same if it's an array. If you try to access array element -1, or you try to access an element past the end of the array, past, you know, in, where in is the length of the array, then you get an exception. Index out of bounds. So you would need to handle that kind of stuff. So a remove student function where you have a an instance variable called students. You write something called remove student, you pass it an index number, you remove that, but if there's an error, then we print out the error. Can't remove student because it's an invalid index position. We could write that code, but you already have the idea, right? Just from me saying that. If you're going to be accessing elements directly by their index number, and there's a possibility that the index number could be wrong, the user chose it from a list, you know, or something like that, then you need to add exception handling to it. Does that mean you have to add exception handling to every time you access an array by its index? No, you know, if you're doing it through a counter, a while loop or a for loop or whatever, you're in strict control over what indexes you're using. Indices, we can use a fancy term. So if a code fragment has the potential of throwing a checked exception, then the compiler requires, note that, checked exception. Checked exceptions have to be handled. There's a couple of ways that you can handle it. One is you can put a try-catch in there. Another is you could buck the error and pass it up. You know, what do I mean by that? You could you could add a throws clause to the method so that if the error occurs, you know, it will just get passed back up to the guy who called the method. So here's their example for something that can generate exceptions. Whenever you want to use a method or constructor from one of the API classes and you're not sure about it, you should look up the API documentation. Use the API documentation to figure out these things. Can the method or the constructor throw an exception? On the API documentation page for the method or constructor, look for the throws section. If there is, figure out whether it's checked or unchecked. So here we've never probably seen the date class being used. Can it throw an exception? We could find out. Why don't we see if we can just get up the Java doc for that. So I'm going to go ahead and launch NetBeans, and we're just going to write something that uses that. And then it uses a little bit of file I/O, and you have to handle file I/O. We've already know that, but we're going to find out exactly what exception it can throw. So I launched NetBeans, new project, Java application, whatever you want to call it. I'm going to call this one November 13. If you take out the package declaration where it says create main class, if you delete everything from the period up, it won't add the package statement. Otherwise, just remove the package statement and move it into the correct folder afterwards. So you saw what I did there, I hope. I know the print's small. I am recording, am I not? Yes. Okay. So let's get that first little bit of code out of there using the date class. So we're going to import java.util.date. Then we're going to try to create a date. See if we can do that. Import java lowercase j .util lowercase u .date uppercase D. Now down here in main, let's create a new date object. Date D is equal to new date. And let's get the string out of it. String date time is equal to D dot toString. And let's print that out, just for funsies. System.out.println the date time. All right. Now, never having used that method before, we don't know whether the constructor throws a checked or an unchecked exception. But we can look it up. Let's look up the date class. So I'm just going to right-click on it and do Show Java Doc. I'm going to do Control F throws. Alrighty. Some of the methods call throws. However, I can't say that it looks like the constructor does. So I think we're safe in not putting any exception handling on the constructor. Right? Because here's all the different constructors and none of them say that they throw anything. Constructor detail, public date. Allocates a date object, initializes it so it represents the time in which it was allocated, measured to the nearest millisecond. There are other ways that you can get time as well. There are system calls, get the current time in milliseconds. That just returns, you know, a number rather than returning an object. And returning a number is great if your only goal is to, you know, measure differences between times, how long this program is running. But if you want to be able to do cool things with the date, like format it into a nice string or convert it to Greenwich Meridian or something like that, it's nice to actually be able to utilize the date class. All right, let's run it then. And it printed out the timestamp. So their example has some other stuff now where they create a file based on that. Do I need to bring that code up a little bit longer? Yeah, there's the code for it. Be kind of fun to see what else you can do with the date object. So just for fun, I'm going to type d dot. Is a date after the other date? Is a date before another date? There's our good old dot equals method that I always recommend we implement. Are two dates equal to each other? And then some of the ones that we always inherit from object. What does notify do? Wakes up a thread. Okay, well, we haven't talked about threads, so we're not going to do that. All right, the ones that are underlined or deprecated to be replaced by datetime.format. Alrighty, well, we'll leave that alone. Okay, so let's go look at their sample code. And here they create a file name. And then they try to create that file. And they're using a class that I don't actually usually do, which is files. But I guess that's as good as any other way of doing it. So let's see. We're going to have to do this, import java.nio.file.star. Let's go ahead and do that. Go up to here. Import. Oh gosh, I've already forgotten it. Maybe I'm just going to totally cheat and copy and paste it where y'all don't get the luxury of doing that. Java.nio.file.star. That gives us the files class. So if I do files dot, we see a whole bunch of different things. Create temporary directory, delete a file. We're interacting with the operating system at this point. If we do it this way, is the file readable? Is it the same file? That kind of stuff. Okay, so we have some fun stuff to do. I'm not going to make mine as complicated as their example, so I'm just going to make a string s or fn for file name, and it's going to be called test.txt, whatever our file name is going to be. Then let's get the path to the file name. So here we're using another class called path. So path with an uppercase P, path lowercase p is equal to paths.get file name. Let's print that path out. Well, let's see what's next. Then they call files.createFile to actually create that file. I do want to print out the path variable just to see what it looks like. System.out.println path. Condense our code a little bit so it all fits on the same screen. Alrighty, so that's the file name for it. Test.txt, that's the path for it. Real fascinating. Okay, now let's create that path. Let's create a file based on that path. So, files.createFile with a capital F, parentheses, path. Files, capital F, dot createFile. We could also change it into a directory name that we were creating. But anyways, path, like that. And if we wanted to set some attributes, we could. Unreported exception. IOException must be caught or be declared to be thrown. So let's show the Java doc for CreateFile and find out what it can throw. So I'm just going to highlight that, right click.
And input output exception.
Yeah, show Java doc, throws unsupported operation exception, file already exists exception, IO exception, security exception. So realistically, we should handle all 4 of those exceptions. I'm going to just copy all that stuff right there, but I must, I'm going to type it in when I get back over there. So we're going to have to put this in a try block. Try this stuff here, files.createPath, and let's put a print message saying that it was created. System.out.println file was created, or create file worked, whatever. Still not digging how it's just underlined that, but I'll leave that alone. Now we have some stuff to catch. 4 different exceptions to catch. I'm going to pare them down. I did a copy and a paste, which you could do too by doing the Java doc, because these are pretty long words. So catch unsupported operation exception. I know I've already typed it wrong. Just get it from Java doc, I swear. Right? So just go to Create File, right click, show Java doc, and if you're not using NetBeans, then go ahead, and just type in exactly what I've got here. Unsupported operation exception EX. That's really probably all we need to do is print out system.out.println unsupported operation. Right. Now let's catch the next one. We've handled that one. File already exists, which is going to be pretty likely if we run this more than once, because unlike them, we didn't change our file name based on the path. Excuse me, but yeah, based on the date time. Maybe that'll be the last thing we do. So catch file already exists exception EX. System.out.println file already exists. And then there's IO exception and security exception. Catch IO exception. That's pretty vague, isn't it? System.out.println IO exception. Kind of curious about that one. Oops, I forgot to put the variable name in my parameter. Catch IO exception space EX. And it's saying that IO exception has already been caught. Well, isn't that interesting? There's an add imports thing, but that's not going to fix it. Yeah, it did. Say what? add import for java.io.ioException. How in the world does that fix the error we just got? Okay, so anyways, I'm going to go add that import. Import java.io.ioException, semicolon, java.io.ioException. Somehow that makes that error go away, which was claiming that we had already caught that error. And then we have our last one, security exception. We're trying to write to a protected directory. Catch security exception, EX. Okay, system.out.println security exception. Now, is the user going to want to see fancy words like that? Probably not, but it's good enough for us to learn with. All right, I'm going to put some comments here. The last brace is the end of the class. The second to last brace is the end of main. And let's print out a done message before we end main. All right, so there's our 4 catches. Did that fix the error that was showing on CreatePath? And indeed it did. Now the difference between this and when we're reading and writing from files is that this does not open a connection to the file. It just creates it. Can't do anything after it. I mean, we don't have anything to write to. You would still have to open the file in order to write to it. But it does create a file. It would be of 0 length. We can confirm that by going out to the directory structure and looking for test.txt. The first time we run, it should say the file was created, assuming that there were no errors. The second time we run, I'm going to be surprised if we don't get file already exists, right? Because it should. Let's build it. Let's run it. And it says test.txt file was created. Let's run it again. File already exists. For fun, let's look at files dot and see what other things it can do. It's always fun to explore classes. Whenever you see a new class, files dot create directory, create temp directory. That's interesting. Create temporary file. If the file exists, see, we could check to see if the file exists, and then we wouldn't have to worry so much about that exception. If you were going to code something where you let the user type in a file name, it'd be better to go ahead and do if files.exist on the path rather than just trying to create a file or something like that so that you could warn them.
Where is it creating this file at?
The file, since we didn't specify a path, is being created in the same directory that the code is running. Well, let's go look for that. What directory are we in? If I go out to projects, right click, properties, I'm in documents, NetBeans projects, November 13, so I'm going to go out there and find it. Yours will be a different path.
Oh, yeah.
Documents, NetBeans projects, November 13. And there's my test.txt. And it does have a file size of 0 if I scroll over there, because we haven't done anything with it. But it's there.
Whenever you, if you use the, you know how every exception has its own message. It doesn't technically show a message if you do, for the file already exists exception, I put in to print out get message, but it doesn't print out anything.
Well, yeah, let's take a look at that. And that's one, yeah, the question is, does get message always print something? If we call get message on the exception object, and our fear is that it doesn't always print. So where I say system.out.println file already exists, I'm going to put another print line, which is just the exception get message, system.out.println. And I'm only going to do it for file already exists because I don't know how to generate these other exceptions. Although we could, try to make it go to invalid paths. If I launch up my command prompt, and I try to go to the T path, it says cannot find the drive specified. So if I try to create a file using a T path, hopefully it will fail. But anyways, system.out.println ex.getMessage. And let's see if it prints anything on that line. All it did is print the file name.
Right.
That's not real useful. Is there anything we could get out of here that actually would be useful? ex.getLocalizeMessage. That's not going to help, really. Same thing. All right, let's try another one.
There's get cause, but I have no clue what that would be.
Yeah, let's try get cause.
No.
Yeah, that wasn't a lot of use. There is one that's going to be chock full of stuff, which is get stack trace. So get stack with a capital S, trace with a capital T, and you can see. No. Get stack trace dot to string. That's what's already recalling. Alright, honestly I've never called get stack trace, but I figured that it was going to just return a string version of all that information you see if you don't handle an exception. Yeah, if you do this, you know, int I is equal to 1 divided by 0. Then you let it blow up, and it prints all this stuff, including, you know, what line number and everything. I would have figured. But why don't we go find out what get stack trace is returning, and then we'll go back to. So I'm going to highlight get stack trace, show Java doc. What does it return?
An array of stack trace elements representing the stack trace pertaining to this throw.
Well, let's see if we can play with that. This is just for fun. But stack trace element array, STE or STA for stack trace array, is equal to ex.get, and you don't have to type this, guys, doing this at home. We're just exploring this a little bit. Okay, so stack trace element, that's an array. Now for every stack trace element EL colon STA, for every stack trace element EL in the stack array, let's just print that out. System.out.println EL. Let's see if that does anything fun. And there we go. There we get our stack trace. What's a stack trace? It should show us what line number our code happened on. There it is, line number 29. And then inside files.java, you know, and inside files.java. And if we wanted to go look at files.java to see what that code looked like, we could probably do so. Click on that error, go look, you know, whatever. That's the thing that threw it. It's always interesting to look at the code that Java provides you, and you realize how little you know about Java even if you've been using it for a decade. But anyways, okay. So that's why I would always print out my own error message, or at least my own error message in addition to the get message, rather than using get message as my only error output. Okay, that was fun, but I'm going to remove that stuff. It's really not part of the exploration of exceptions. But knowing that you can get the stack is useful, because once you add exception handling, you're not going to be seeing those nice red errors where you could click on the line number. So your error messages need to be clear enough to indicate very precisely what the problem is so that you would know where to go and modify it. Now, doing something like file already exists error on line 29, line number 29, putting hard-coded stuff like that, I don't do that. But if this is a function, if this is a method other than main, you could put what method you're in. File already exists in whatever method. Anyways, just be careful. Make sure your error messages are informative. So this is an example of checked error handling. We weren't able to get this code to work at all until we added some try-catch that actually caught those errors. We could have done a more generic error. We could have just caught IOException, I believe, and it would have caught all of these. I could be wrong. I'm going to highlight all that stuff. Don't do this. This is just my experimenting. And see if it still compiles. And it should, because all of the errors that I listed are in fact IOExceptions. So when I run it, it's just going to say IOException. I don't know which IOException it was, but it was an IOException. The file does exist. The reason that works is because that's the generic version of the exception, and then the other ones, the file already exists and the unsupported operation, are more specific ones. I'm curious about what error I'm going to get if I try to create it with a drive letter that doesn't exist. So t:\\/ test.txt. Why 2 backslashes? Because that's how, if we only had one, it would think it was an escape sequence. It would think that was a tab, right? \t is a tab. That's not going to be a good file name with a tab in the middle of it, so I'm using \\\. Let's run it and see if we get any nice error. If it just says, yay, great, I did it. Okay, we got an IOException, and it would sure be nice if we could query the object to find out specifically what it was. Drive does not exist or something like that. I don't know how to get that information out of it, so I'm sure there are other ways of checking to see if the drive exists before you try to open a file to it. I'm going to undo that.
So if you create a file, or that's the file name, but you put the path to the file, does the file name and the path supposed to be the same thing? Because
yeah, what does paths.get do, and how do we actually set it to an honest-to-goodness path? Well, I'm going to go back to drats, I lost my, anyways, like my downloads directory. I'm going to copy that path. Again, we're just experimenting here, but could this whole thing, could we put paths in like that? C:\users, user downloads. You saw how I copied the path. I went to the directory I cared about, and then I just went up, to the path bar up there, Control-C'd it, and pasted it there. Is that going to work? Am I going to create a file test.txt in that directory? And the answer should be yeah. So you can specify the full path. If you don't specify the fully qualified path, it just creates it in whatever directory that Java is executing the.
So the file name and the path are the same thing? This is my question. I don't understand how, you're creating a file name, but you passed in the whole path.
Well, I called it file name here, but the file name is not really the path. That really is the file name. This really is the path. But we created a path to the file that included the whole thing. So it's close enough to say that a file name is the path plus a file name. But they are treated as different things, certainly in Windows. Yeah, because this is a directory and you have other functions, other methods for manipulating directories, where you can create a directory, where you can create a folder with a call, and it does something different. It doesn't create a 0-byte file, it creates a directory. Okay, so here we're going to modify our code a little bit, or we're going to, I don't know. We may not even use this method, but we're going to demonstrate creating a method that throws an error, or uses a throws clause. This one doesn't actually throw the exception, it just uses a throws clause to say, oh, I'm not going to handle it. So public static void create file string file name. So path p is equal to path dot, or new path file name. Okay, I messed that one up. Paths.get file name. Okay, it's not a constructor, excuse me. Path is an abstract class, meaning that you cannot instantiate it. So path p is equal to path.get, get the path to that file name, and then files.create that path. Am I still getting an underline there? Cannot find paths.get. Okay, I've botched that twice. Path p is equal to paths.get file name, and then files.create directories path. And then it goes, I'm not going to compile because you're not handling that checked error. Oh, I called it path p. So files.create, and I didn't want create directories. Where'd I go? Oh, whatever. I'm not going to even ever run this code. So if I hover over, I get unreported exception, IOException, must be caught or declared to be thrown. So I'm going to come up here and say throws IOException, like that. That passes the buck. If the error occurs, then we're not going to handle it here. It's up to the client code, the driver code, to handle that. So we think, okay, great, we're all done. So I can just call create file and pass in a file name, whatever, and I'm not going to run it because it's going to try to create that as a directory, you know. But anyways, there we go. Ah, drats. I'm still going to have to add exception handling. Oh, lowercase f, uppercase f, create file, lowercase f. And here's our error. Unreported exception must be caught or be declared to be thrown. So we are going to have to put that in a try-catch block because this guy can throw it. So just like if we had this code right here inside it, we'd have to catch it. We can put this code in a method and say, okay, but it throws that exception and we still have to handle it out here in the client code. So we could have taken this code right here, create file, system, you know, that stuff, and put it into a method, but eventually we would have had to add some exception handling for it. So I'm just going to comment that out. And this is so pathetic that I am going to actually change create directories to create files. Create file. And let's go ahead and actually use this. We've written the function, we may as well use it. Nah, not going to bother. Where would we use it though? We would use it right here. Instead of files.createPath, we would call our own function. Heck, let's do it. Keep waffling on it, may as well do it and stop waffling. So create file path, like that. And I goofed, it wants a string there. So forget it, I'm going to undo that.
And then when it says unreported exception must be caught or declared to be thrown.
Right.
Didn't we declare it to be thrown? If you do throws IOException?
We did here. Where are you seeing that? Let me run it.
Whenever I try and do...
Oh, I forgot to...
yeah, the line you commented out right there.
Okay. But we've never handled it. We just said that it's being thrown here. It's being thrown to here, so we have to catch it here.
Okay.
Or the ultimate cheat is to add a throws clause to main. And that's horrible. Never, never do that. But if we want to get this to work, we're going to have to do a try. We're going to have to do a catch IOException. System.out.println IOException, creating file, like that. But you have to handle it somewhere. Just because we add a throws clause here did not magically make the problem go away. It just passed the buck, and we have to handle it where we call it in our client code. Does that make sense?
Okay, yeah, but then what's the point of putting throws and IOException when you can just handle it down
Yeah, you could just handle it down here, but maybe you don't want to. Yeah.
You
Maybe
already have
if-
it created in the client class, what's the point in doing it in your method?
Huh?
If you already have it created in the client class, what's the point in doing it again in the method?
Yeah, we already have some good exception handling in the client class. So if we were starting to encapsulate stuff, there's no reason to go and let's do this. Let's take this guy, create file, and move him to his own method. So we're going to change this to a method called CreateFilePath that takes in path. And all it's going to do is call files.createPath. So now that we have that CreateFilePath, we're going to scroll up here. We're going to add it as a public static method. Public static void CreateFilePath path b, and then files.createFileP. Right now it's going to warn me you're not handling that exception, so I'm going to come up here and say throws IOException. That makes the error go away. And since I was already handling IOExceptions down here in the code that's calling this, I'm not going to bother putting it here as well. So as you're designing your code, you just figure out where you want to handle it. Whether you want everything to throw exceptions back up to some client code and it has to handle it, or do you want each method to atomically handle it? So we added that method here. We've got two methods here. You may need to take a moment to look at them. Honestly, I meant to make this one right here and this one be the same, but I forgot to. Hey, we could overload it, right? One version of it, you accept a file name. The other one, you accept a path. Let's do that. So I'm just going to copy this method name, CreateFile, and paste it onto our newer version. So now we have two methods with the same identical name, but one takes a file name and one takes a path. Makes it a little bit more flexible to call. We don't have to sweat it. But now we got to go back down here and we got to fix that call. So inside our try block down there, create file. Lowercase on mine, uppercase if that's how you made it. All right, we've already demonstrated throwing our own exception, but we're going to do it one more time anyways. So public static, this is just going to be a divide function, as always. It's going to do a divide, so div of int x and int y. And we're going to check, and if y is 0, we're going to throw some kind of error. So if y equals 0. It's a problem. We need to create a new exception and throw it. What kind of exception are we going to throw? Let's go back and look at our exception hierarchy tree. Yeah. We have runtime exceptions, which are unchecked exceptions. Good enough. Let's just pass that one back. You can create your own exception by inheriting from the runtime exception class. Maybe that'd be a cool thing to do. If we're going to do that, we'd have to go and create a class that inherits from runtime exception. So, but I'm putting it in the same file. Bad. So private my exception extends runtime exception. And it was with a capital T, wasn't it? No? I forgot to put class, excuse me. Private class my exception extends runtime exception. And if this gives us too much grief, we're going to get out of it. Modifier private not allowed here? Okay, fine, I'll take that out. Okay, I'm going to give it a better name than my exception. My divide by 0 exception, or my no zeros exception. So I have that exception. I'm not going to even put any code into it. I don't need code in it in order to use it. I just need to remember this exception name here, my no zeros exception. So down here, if y is equal to 0, let's create a new exception. My no zeros exception ex equals new. Notice I copied it and pasted it. New my no zeros exception. And then throw it. And since it's not a checked exception, I'm not going to have to put a throws clause here. What would happen if I did? Throws my no zeros exception. Is that going to be an error of some kind? No, doesn't look like it. It's not a bad thing to do, right? That way if somebody was looking at our code, even without scrolling down into it, they would know, okay, this can throw an exception. All right, but if we didn't hit that problem and we didn't throw an error, let's actually give our result. Return x divided by y. We have now written a function called div, which if it encounters our condition, y is equal to 0, it will throw an exception. And since we derived our class, since our class's superclass, our base class, is an unchecked exception, we don't have to handle it, but we could. So here we could do int result is equal to div. I really wanted all that on one screen. Yeah. div 1, 0. I don't have to handle the exception, but if I wanted to, you know what to do. Enclose this in a try block and then catch my no zeros exception. So try this stuff, catch my no zeros exception ex system dot out dot print line curses divided by 0. We're trying to divide by 0. No div by 0, please. Alrighty, that's how to create your own exceptions. You could create your exception class that inherits from a checked exception, and then you would be forced to add the throws clause to your method, and you would be forced, the programmer who comes after you or yourself would have to catch it, or again throw it somewhere else. Alrighty, I think that's pretty deep into exceptions, even though this is going to, even though the PowerPoint's going to seem like we're not that far into it, but we really are. Unchecked exceptions, checked exceptions. A try block can throw different types of exceptions. If several statements within a try block can possibly throw an exception, you can provide a generic catch that handles every type of exception, or you can provide a sequence of specific catch blocks. We have done that. That's how we handle it. That's what I recommend. No generic catch. Don't ever just do catch parentheses exception space EX. Sure enough, that will catch every exception, but it's really, really tacky. Like that. That's horrible. Never do that. Check that out though. You could get the name of the exception and then print that out, you know. That would be a generic exception handler. It's still tacky. Catch the exceptions that you need to catch. There is a syntax for writing a single catch that can capture more than one exception. Check this out. You use a single vertical bar like that. Let's go demonstrate that. Let's come to our code and let's see. What were one of the exceptions? Like arithmetic exception is an unchecked exception, or number format exception. So we could do this. Down in our code, I'm going to put this at the very top line of main, just to make it easy to find. Int I is equal to 0. Try this stuff. I is equal to I divided by 0. You know, it's just stupid. But, you know, let's put some catches, but we're going to declare multiple catches in the same line. What kind of catches are we going to do? We're going to do arithmetic exception. Is that good enough? Arithmetic exception space vertical bar space number format exception EX. And in either case, we're just going to print whoopsie. Is that a good way to handle it? No. But we have written a catch statement which will catch either arithmetic exceptions or number format exceptions. I don't remember whether divide by 0 gives us an arithmetic exception or if it gives us something more specific. Let's find out. I'm just going to run it and see if that actually caught it. And it did. It print whoops. So arithmetic exception was good enough to handle divide by 0. So do note that you can catch multiple exceptions with a single catch. We could have modified our code down here if we saw any need to. Like maybe we didn't want to differentiate security exceptions from unsupported operation exceptions, you know, whatever. We could have caught both of those in the same time. Using the throws clause to postpone the catch, we've talked about that. You don't want to handle it inside that method, then you can throw it so that the client code that uses it, and that client code, if it's a method, could throw it somewhere else. You know, you could have a chain of exceptions being thrown all the way back up to your ultimate, you know, driver code. Clean up with the finally block. Sometimes you need something that executes regardless of whether an exception is thrown or not. There is a finally clause Have we talked about finally yet?
Yeah, because I asked about it.
Okay.
Well, what was
Did
I
we
not
put it
to-
on lecture though?
I was
Do
like,
you
I don't
remember?
remember.
Okay.
I don't remember that part.
So we'd better do finally. Let's go in to our code here. And one of our proper try catches. Here, this one. The one that says curses no divide by 0, please. Really, you could do it on this one too. Yeah, let's do it on the very top one where we did whoops. Finally. After that's done, let's do something. What you do is you put some kind of cleanup code here. Something that needs to happen regardless of whether the try succeeds or fails. But this could get a little bit weird. I mean, it's pretty easy to understand like that. You try this. If it succeeds, great. It then runs the finally block. If it fails, whoops, it does that, and then it runs the finally block. Let's kind of prove to ourselves that that works. Let's put an extra print statement here. System.out.println. Division OK. But if we catch the error, we're going to say error caught. Whoops. And then our finally is going to say, OK, finally doing something else. So when we run it, it's not ever going to say, until we change that value, division OK. We could put something before it. Let's do that. System.out.println going to divide now. So we have that. Println going to divide now. I is equal to I divided by 0. And then system.out.println division OK. Then we have a catch. Arithmetic exception, arithmetic or number format exception, EX. We print error caught whoops. And regardless of whether an error is caught or not, we're finally going to do this. Okay, finally doing something else. Let's run it and watch. So up here, going to divide now. Error caught, whoops. Okay, finally doing something else. Okay, so that makes pretty clear sense, I hope. Let's change this so that it actually succeeds. You see where it says I is equal to I divided by 0? Let's make it I is equal to I divided by 1, so that'll work. Now we're not going to see error caught whoops. So we see going to divide now, division OK. OK, finally going to do something else. So what you do is if there's stuff that needs to happen regardless of whether you catch the exception or not, you put it in a finally clause. And some languages don't support finally. Unless it's changed recently, C++ doesn't have a finally clause, unlike Java. C# does, I believe. So the weirdness comes in if you're going to return inside the try or inside the catch. Like, what if this error is so bad that we don't want to do anything else? If we get our error caught whoops, we just want to bail out of main entirely. So let's put a return statement here. What is going to happen? Is it going to execute the finally code? Yeah, it sure is. And if you think too much about it, it starts seeming weirder and weirder. So maybe I shouldn't be focusing on this, but I want you to give it a little bit of thought. You run it, it's going to work. So it's not going to have returned out of it. It will have successfully run everything that we've written. But let's restore it to its prior error condition. I is equal to I divided by 1. Let's change that to I is equal to divided by 0. So that's going to generate an error. It's going to run down here. That error is going to be caught. We're going to print error, whoops. then it's going to return. But before the return can successfully happen, it has to jump down here to finally execute that stuff. Then it'll come back up and it'll return. So even if it's counterintuitive, even if it doesn't look like it's going to print this finally stuff because we have a return here, it will. And so going to divide now, error caught, whoops, okay, finally doing something else. So even though there was a return statement in that catch clause, the finally happened anyways. And the same is true as if that was a break. Like you have all this stuff in a while loop, and if the exception happens, you want to break out of the while loop. The finally code will get executed before the break is successfully done, just as in here the finally code was executed before we finished returning out of it.
They say if you put a system.exit and where the return is, it doesn't do the finally block.
Yeah, if you have a system.exit, you're absolutely killing the program. You're putting a bullet in its head right then and there. So that would be a way to stop it from doing the finally. Okay. We hate this error so much. System.exit -1. You know. Sure enough, it's not going to run the finally.
And if it does, we better just run.
Yeah. We get error build failed because we bailed out of it with a non-zero value, so it knows that it failed, but we did not get our finally. Do I ever use system exit? No, but it's there. I think if I did a lot of stuff for an environment where these things were being invoked, I won't even speculate. There's one more version of try, which we will use again at a later point. This isn't even demonstrating it. Yeah, here it is. Now, have we talked about print writers yet? No, so this line of code is not going to make a lot of sense. But let's zoom in on it anyways. It's called try with resources. What happens is you use try, and then inside parentheses, you create an object that you need in order to do all this stuff. And then as soon as it hits the end of the try or it hits the end of the catch, then this object is dereferenced. You know, that object goes away. Why would you do that rather than put this here inside the try block, which is maybe your expectation, because then that object would not be available in your catch blocks. Let's give an example of that. May as well do that. So we're going to demonstrate a try with resources. I'm going to just put it up at the top of main again. So try this stuff. Let's just make a new string. String s is equal to new string parentheses hello. Alrighty, that's not a good example. Let's skip it, and we're going to do we're going to do try with resources when we actually are doing honest goodness file IO, which is the next lecture. Just recognize that syntax. If this had worked, if I had put this in here, right here, don't bother typing it in, then after our try and our catch, and our finally, after all of that was done, then this would fall out of scale, fall out of scope, and any closing that needed to happen, you know, to close that file would occur. So that's a nice way to handle it, so that you don't have to open your file beforehand, do a bunch of stuff, and then explicitly call a file close. Now, honestly, that's how I always do it, is I have my open code here, you know. But the nice thing about doing it this way is if you had to return out of it, if you had a return statement in the catch or something like that, then it would in fact close the file because it was allocated here. And you know, just like a finally gets executed before the return does, the cleanup of removing this object would happen. I think that's overly stating it broadly, but then that's kind of a generally right, but not specifically right. All right, let's stop there. Close this stuff. Go ahead and upload it. Oh, and projects. The idea behind the projects, you may have seen them down there, I'm going to bump them up to the top and post a notice about them, is that if you do a project and you do it well, and you like your project grade, you can use that project grade as your final grade, final exam score, and skip taking the final exam. So doing a project is a way to skip taking the final exam. On the other hand, if you try to do the project but you fail to do the project, you make a low grade on it, or you give up on it, take the final exam. Yeah. So I'd like for y'all to do the projects. That's why I dangle the option of skipping the final exam, because I think that they're a lot of fun. There are 3 posted out there. I'm going to add one more, and one person has already done a project, you know, but nobody else has. So I encourage you to do the projects. Hey, that'll make finals week easier, right?
Yeah. Let's do it.
All righty.